This is video number 3 for sections 9.1 and 9.2, multiplying radicals. We've already figured out that you can only add and subtract radicals in very limited situations. What about multiplying radicals? Well, it is also limited, but not quite as much as for adding and subtracting. Here's the rule. You can multiply any radicals that have the same index. In other words, you can only multiply square roots by other square roots, or cube roots by other cube roots, but it doesn't matter what's in the radicand. As long as the index is the same for both, you're all set. How do you actually do the multiplying? Well, let me write down the rule for you. If I want to do the nth root of x times the nth root of y, they're both nth roots, so I know I can do it. It's very, very straightforward. All you get is another nth root, and on the inside, in the radicand position, you simply get the product of the two pieces you had before. It's very straightforward. In fact, we've been using this rule backwards throughout this entire lesson. Every time we've been splitting up one of these radicals into the good radical and the bad radical, we've been using this rule. Now we're just saying, look, if you want to put it back together as a single radical, of course you can. Well, let's take a look at some example problems here. So my first one is two square roots that are being multiplied, and as long as they're both square roots, I'm safe. When you multiply two square roots, you get a square root. That's what this rule is trying to communicate. When you multiply two radicals together, you get a radical. And on the inside, in the radicand position, you simply get the product of the two pieces you had before. In other words, just multiply 5x times 15x, and you're all set. 5 times 15 is just 75. X times x is x squared. When I multiply two square roots, I get a square root. Now, is that my final answer? Well, maybe so, maybe not. What I do have to check next is to see if I can do any simplifying. In other words, the good, bad, radical stuff. I think for this guy I can. Let me give myself a good radical and a bad radical. 75 is not on the list, but 25 is. 25 goes in 3 times. And x squared is on the list. Then I can take out my good stuff. Square root of 25 is 5. Square root of x squared is x. The bad stuff stays behind. Here then is my final answer to the problem. Okay, let's take a look at the second example. I have 2 cube root 7 times 3 cube root 2x. The first thing I always check is, can I even do this multiplication? And of course I can, because these are both cube roots, so I'm safe. What about the coefficients? Well, you have to remember that between the coefficient and the cube root, there's just a times. That just means 2 times that. And the other one is 3 times the radical. So really, I just have 4 things here being multiplied together. If it helped you, you could even rearrange the order of those 4 things. You could say, well, I have the 2, and I have the 3, and then I have the first cube root, and then I have the second cube root. And if that helps you, by all means do it. What I generally just remember for myself is, look, basically the outside stuff stays on the outside and the inside stuff stays on the inside. So when I look at this, I say, okay, outside, 2 times 3, 6, done. And then I say inside. Well, when I multiply 2 cube roots, I get a cube root. That's what the rule says. How do I figure out what goes on the inside? Just multiply the previous 2 insides together. And that would, of course, be 14x. 6 times the cube root of 14x. Before I put a box around this, I should double check to see if I can do the good radical, bad radical stuff. However, I know I don't have enough x's. It takes at least 3 of those. And 14, if you check the perfect cube list, there are no numbers on that list that go into 14. So I have no way to break it down any further. This would then be the final answer to the problem. Let's take a look at the third example. This is somewhat complicated looking here at the start. I got a lot going on here. What your brain is supposed to be telling you is, boy, this looks an awful lot like a FOIL problem. And that's exactly what it is. This is a FOIL problem. I've got a binomial here times another binomial here, so we will treat it just as a FOIL problem. First, and then outer, and then inner, and then last. Let's work through each multiplication. Remember, outside stuff stays on the outside, inside stuff stays on the inside. The most complicated one is the F part of the FOIL, these first two guys. I have 2 times 3 on the outside, and then I have 2 square roots. When you multiply a square root, you get a square root, and the new radicand is the product of the old radicands. So that's x times x, which is x squared. Then I go to the O part of the FOIL. They're both positive, so I'm going to write plus. Outside stuff stays on the outside. That's 2 times 1, which is 2. And the only inside part is the square root of x. Here comes the I part of the FOIL. Looks like it's minus. 4 times 3 is 12. And then that square root gets carried along there. And then the L part of the FOIL, negative 4, positive 1, makes minus 4. Okay, now I should look for opportunities to simplify. That's the good, bad, radical stuff. I really don't even need to do good, bad, radical because this is the only one that's going to simplify. It's already good. X squared is on the list. Just work it out. Square root of x squared is x. These other two guys, I don't have any way to do the good, bad, radical. There just aren't enough x's in there, so I'll just recopy those parts. The last thing that I should check for is, do I have any like terms or like radicals that I can combine? 6x, I don't have any plain old x's. The 4, I don't have any plain old numbers, but these two in the middle, these are like radicals. Root x, root x. Well, that means I can go ahead and carry out that subtraction there. So let's see, I can't do anything with the 6x. For these two middle guys, 2 and negative 12 makes negative 10. Remember, you just combine the coefficients. The rest of it stays the same. And then that minus 4 at the end. And I know it doesn't look like that great of an answer, but that's the best I've got. I can't simplify this any more than this expression here. In the box on the side, I just wrote down for you what I think is a helpful thing to learn and remember. And that is, when you have multiple things going on in these problems, what part should you tackle first? And the answer is, always do any multiplications that you can do first. Then try to simplify. That means your good, bad, radical stuff. And then at the end, you're going to be dealing with adding or subtracting if possible. All that leaves us with is division of radicals. That turns out to be a little bit more complicated, and so we're going to tackle that in the next lesson.